All right, today we're going to start our next unit on exponent rules. This is unit 13. In your table of contents, add the title for today's lesson, exponent rules, and then on the next clean sheet of notebook paper in your spiral notebook, write the title, exponent rules, at the top of your sheet of paper, and the EQ for today. How do I apply exponent rules to simplify expressions involving exponents? Hit pause. When you're ready to move on to the notes, hit play. All right, copy this into your notes. I want both things in your notes, the definition and this example here, and make sure you label everything that's on this. So you need everything on the slide copied into your notes. Hit pause and copy that down, and then when you're ready to move on, hit play. So before we can learn what we call the rules or the laws of exponents, we first need to know what is an exponent. Exponents are shorthand notation that allows you to write repeated multiplication more effectively. So we're going to see exponential form look something like this. We're going to have a big number, which is called the base, and we're going to have a little number up top, which is called the exponent. The base is the number that is being multiplied, and the exponent tells us how many times we multiply this number times itself. So since it's 4 to the third power, we multiply 4 times 4 times 4. I multiply it 3 times because the exponent is 3. All right, also copy this into your notes. How can I multiply exponents with the same base? You are going to add the exponents. And I want you to underline that second part there where you're saying add the exponents. Underline where it says add the exponents. That's our little trick for multiplication. We add the exponents. Okay, so this works when we have two numbers written in exponential form that have the same base. What that means is the same big number. So in this example right here, we see the base is 7 in both of those numbers, and they're being multiplied together. So what you do in that case, you add the exponent. So I add 2 plus 3. What is 2 plus 3? It is 5. So 7, the base stays the same. That doesn't change. You're just adding the exponents. Okay? All right, next. Call this example 1 in your notes. Let's do this together. Example 1. All right, it says simplify the expression. First, I want you to copy this original expression. Copy that down. 3y to the 4th power times 5y to the 7th power. Now, if we have two different terms being multiplied together that have the same base, we know that we are going to add their exponents. But also notice we have a number in front of each of the variables. We call those coefficients. What we're going to do with those numbers is multiply them together. So for our coefficients, I start by saying 3 times 5 is 15. Then I look at my exponential form, my powers with the same base. I have y to the 4th power, and I have y to the 7th power. Now remember my first law of exponents for multiplication. If the bases are the same, I just add the exponents. So I would say this is y to the, what is 4 plus 7? It is 11. So my final answer is 15y to the 11th power. Again, you just multiply the coefficients and then add the exponents. Keep that base, that y, the same. All right. Here, we don't see any coefficients. We just see k to the 3rd power times k to the 6th power. On your own, I want you to call this example 2. I want you to copy the problem and work it out on your own. Hit pause, and when you're ready to check your answer, hit play. All right, does this have the same base? Yes, k and k, it's the same base. So I just add the exponents. 3 plus 6, I get k to the 9th power. And I pulled this problem straight from the IXLs that you're going to be doing in a second. What you're going to do is you're going to type the k, then you're going to click on this button right here, and that's going to give you the exponent, and then you type in the 9 and press enter. All right, next example, call this example 3. Try it on your own. Hit pause when you're ready to check your answer. Hit play. All right, do we have the same base? Yes, the same base as W, so then we just add the exponents W to the 12th power. And we're done. All right, next, so we've done exponents and multiplication. When we have multiplication, we add the exponents. The second thing for today is exponents and division. So copy this into your notes. How do you divide exponents with the same base? To divide exponents with the same base, subtract the exponents. And I want you to underline there where it says subtract the exponents. Okay, so when we are multiplying, we added the exponents. When we're dividing, we're going to subtract the exponents when we have the same base and those numbers are the exponents. Copy that into your notes. So then we see this example here, 7 to the 8th power divided by 7 to the 3rd power. Remember, when we have a fraction, that means division. So again, do we have the same base on both of these numbers? The base here is 7, the base here is 7, so yes. Since it's division, I'm just going to subtract those exponents. So I'm going to do 8 minus 3. What is 8 minus 3? 5. So that's how I get the 7 to the 5th power. All right, call this example 4 in your notes. Do this with me now. Example 4. All right, looking at the bases, do we have the same base? Here, the base is G. Here, the base is G. So I know that I'm going to have G. And then what do I do with those exponents? Since this is a fraction, it's division, I'm going to subtract 35 minus 23 is 12. So my answer is G to the 12th power. All right, example 5. Try this one on your own. Copy it down. Try this one on your own. Example 5. Do we have the same base? We have P, and we have P, so we know it's going to be P for our base. And then since it's fraction, we're going to do 5 minus 2, which is 3. So P to the 3rd power. Again, typing this into into IXL rather, you're going to type P, then you click this button, and then it'll give you the exponent you type in 3. Hello. Okay, next one. This is example, what am I on? 6. Example 6. Call this example 6. Our exponent's always going to be positive. Look what happens here. When I do a to the 4th power divided by a to the 9th power, I know I'm going to get a as the base, but I have to do 4 minus 9 for the exponent. Now, let's just remember our integer rules. 4 minus 9, 9 is bigger, okay? So I'm going to be getting a negative number. Remember our T-chart. 4, is it positive or negative? Positive. 9, is it positive or negative? Negative. Bring over the smaller one and subtract. And it's 5. And then we put the sign on our answer. So our answer here is going to be a to the negative 5th power. So can I have a number written in exponential form with a negative exponent? Yes. You'll have a few of those on IXL. Okay, sometimes you will also see, what do we see on the bottom of this fraction here? It's just a G. Any guesses on what the exponent is if we don't see a number there? You said 1, you're correct. Okay, so if we see just G, that is the same thing as G to the 1st power. Make yourself a note in your notebook that just G is the same thing as G to the 1st power. Okay? Anything when it doesn't have an exponent, it has like an imaginary, invisible exponent of 1. Alright, so now I'm going to apply my exponent rules. G, I have to subtract the exponents. What's 17 minus 1? 16. Now, it is a common mistake here easier to think that because there's no exponent that means 0. If you say it's 0, that's going to give you the wrong answer. Okay, when we don't see an exponent there is a little exponent that is a 1. All right, at this point you are ready to start on IXL. We're not giving you any digits for this little mini unit that we're doing. There are just a few IXLs for you to do, and that list is on Google Classroom. You also have a spiral review for this week to work on. If you need help, raise your hand.